Now look at the next set of questions, which is based on the passage. A current loop ABCD is held fixed on the plane of the paper as shown in the figure. The arcs BC having radius B and DA having radius A of the loop are joined by two straight wires AB and CD. A steady current I is flowing in the loop. Angle made by AB and CD at the origin O is 30 degree. Another straight thin wire with steady current I1 is flowing out of the plane of the paper is kept at the origin. Okay, now we have this current loop ABCD in which BC and AD they are two arcs, AB and CD they are the straight line current segments, and we have one more straight thin wire which is into the plane of the paper, and the current is coming out of this point O, and the angle made is 30 degree by AB and CD. Okay, now we have to find out the magnitude of the magnetic field due to the loop ABCD at the origin O. Okay, now the current in AB and CD will have no magnetic effect at point O because the current element CD and AB they make zero angle with the radial vector which points at point O. So there is no contribution of current due to AB and CD. So whatever magnetic field is there is only because of the arcs AD and BC. Okay, so magnetic field at center O will be resultant of AD and magnetic field due to BC. Okay, now one more thing, the sense of flow of current in both AD and BC is opposite, so their magnetic field will be opposite in direction. Okay, now we will find out the magnitude of magnetic field due to AD. The magnetic field due to AD will be given by mu naught I upon 2A, where A is the radius, times theta by 2 pi, where theta, which is 30 degree, will be given by pi by 6 radians. So mu naught I upon 2A theta by 2 pi will be pi by 6 divided by 2 pi. So if we calculate this, we will get mu naught I upon 24A. Okay, similarly magnetic field due to BC will be given by mu naught I upon 24B. Okay, so net magnetic field is the resultant of these two which are acting in opposite directions. Okay, due to AD the magnetic field is coming out of the plane of the paper, and due to BC it is going into the plane of the paper. So the net magnetic field is mu naught I upon 24 1 by A minus 1 by B, and if we calculate this, solve this, we will get mu naught I upon 24 AB times B minus A. Okay, now the second problem with the same passage is due to the presence of current I1 at the origin. Now you have to find out the correct option. Now the force on AB and CD are 0. No, because due to the flow of current at O, the magnetic field will be like this. It will be forming closed loop in this sense. Okay, so if we take any point on the wire AB or CD, the magnetic field is perpendicular to the current element. Okay. However, the magnetic field is parallel to the current element on the arcs AD and BC. So since AD and BC, in which the current is flowing, which is parallel to the magnetic field at any point on the arcs, so there will be no magnetic force that would exist on AD and BC. However, magnetic force would exist only in the case of AB and CD. Okay, so option B, the force on AD and BC are 0, but on AB and CD it is not 0. Okay, so option B is correct.